Hello, in this checkpoint they want us to look at the joint function random variables in x and y is given by this function. It's a piecewise function where it's equal to x squared plus y squared divided by, that's 16,250, as long as x is between 0 and 15 and y is between 0 and 10. And then otherwise it's just going to be 0. So the idea is that if we integrate this over that particular domain, this is our domain here. X goes from 0 to 15. Let's mark 15 here. Y goes from 0 to 10. Let's mark 10 here. So if we take this integral over this whole domain, then the total area should equal to 1. Okay? All right, so that's not what they want here. They want us to find the probability that x is at most 10, x value. So this is your x value at most 10. So at most means up to and including 10. So at most 10, so everything from here to 10. And then y is at least 5. So at least means bigger than or equal to 5. So from here on up. And at most 10 and on up. So this should be the area that we're looking for. So over this whole original area from 0 to 15, 0 to 10, we're going to get an area of 1. Now, if you only cut this up here, you should get a probability value that's less than 1. So one of the keys is that the probability should always be between 0 and 1. All right. The notation, not important, but I think it's good to get some notation for this properly set up. It tells us that our x values, and that's my capital X, is at most 10. So it's going to be less than or equal to 10. And let's assume that we're in a domain, so we know that we're going to stop at 0, from 0 to 10. And then your y value is going to be at least 5, so it's bigger than or equal to 5. And again, it's understood that we can stop at 10, or we can look at the piecewise function and say, oh, after 10, after y is bigger than 10, it's all going to be 0 anyway, so it's not going to be counted. So this is our official setup for the integral, and essentially we're going to go through these limits. And so if we want to explicitly write these limits, your y goes from 5 to 10 and your x goes from 0 to 10. Okay, and it's just a matter of putting those values into the integral. Okay, let's go ahead and do that. This is going to be a double integral. These are constants. Your region is a rectangular region, so it doesn't really matter what order we do this in, and especially since the function is really not forcing us to go into some strange techniques. It's just going to be pretty straightforward, so it doesn't really matter which way we do it. So it's x squared plus y squared, 16,250. And let's just, since we have our y up there first, let's do dy and then let's do dx. So y goes from 5 to 10 and x goes from 0 to 10. Okay. All right. We got that constant. We'll take that constant out. So it's 1 over 16,250. And then we'll integrate with respect to y. This is going to be x squared y plus 1/3 y cubed. And we're going to integrate this from 5 to 10 dx. So maybe I just saw why we probably should have integrated with respect to x first, is they're going to be zeros, but then, you know, I think that's a give or take payoff. All right, we'll put in 10 and we'll put in 5, so we'll have this constant 16,250, and then let's put 10 in for y. Remember that these are y limits, and so y is going to be, let's put the integral again, because I decided to keep this kind of going in the flow instead of I usually kind of capture the middle part, the iterated integral, the inside part, and do that off to the side, but here we're kind of doing it all at once. So this would be 10x squared plus 1/3 times 10 cubed is 1,000, and we're going to subtract off when we put 5 in there, plus 25 times 5 is 125. Dx. Okay, so the rest of this is just kind of algebra work, and then one more integral that we have to do. So 5x, 10x minus 5x is positive 5x. Oh, that's x squared, and then we have a constant. I think this is 875 over 3. All right, I'll continue doing the work here. We got 1 over 16,250, and we will integrate this now. This is 5/3 x to the 5th plus 875 over 3 x, and we're evaluating from 0 to 10. So the 0 will make it disappear. We just need to worry about what happens when it's equal to 10. So let's put 1 over 16,250, and let's put 10 in there. Oops, this should be to the 3rd power. So that's 1,000 times 5, that's 5,000 over 3, plus this is 870 over 3. And then, well, this will turn out to be a really big number. Let's just, if we put it in the calculator, I ended up getting about 0.282, which is equivalent to about 28.2%. So usually probabilities, we can write it as a decimal, as a fraction, or as a percentage. All right. Okay, I hope that helps.